Okay, for today's lesson in 5.2, you may want some graph paper. I've got some here laying on that front desk if you want to come one at a time and get a sheet. It's up to you, but you can sketch these on notebook paper as well. Okay, 5.1, which I went over yesterday. I posted notes and a lesson video for it. 5.1 just dealt with introducing you to polynomials, classifying them, learning how to pick out degree, and the degree actually helps you find end behavior, which is one thing we're going to use to graph polynomials. Okay, so this may be overwhelming at first, but just hang in there, because as we start graphing them and applying these steps, hopefully it'll come easier to you, because this can be intimidating looking at it. All right, step one. In order to graph a polynomial, well, polynomial graphs, they're going to be smooth curves, continuous. You're not going to have any holes or gaps in your graphs, and they definitely should not look like a line or be linear. So polynomial graphs can be curving all kinds of ways, like parabola is a polynomial, all of that. The first thing you're going to do, you're going to determine what your graph is doing on the left side and right side by finding end behavior. And the way that you do that was in 5.1, you're going to determine your degree of your polynomial, which is simply your highest exponent. And we're going to look at the coefficient in front of that. So for example, if I have 2x cubed, x to the third power, 3 is my highest exponent, I'm going to look at 2, it's positive, and I'm going to use that to determine, is my graph going up on the left side, down, is it going up or down on the right side? Okay, then the second step, we're going to use the x-intercepts, and later on in step 4, we're also going to use the y-intercept to help us graph it. So in step 2, you're going to find the zeros or the x-intercepts. That is the same thing. You'll see it called both. You may have to factor your polynomial if it's not in factored form. And to get the zeros or the x-intercepts, you take each factor, set it equal to 0, and solve. So find x-intercepts, may have to factor, set each factor equal to 0, and solve to get your x-intercepts. There may be 1, there may be 3, there may be none. Okay, on step 3, once you find your x-intercepts or zeros in number 2, then you determine their multiplicity. And all multiplicity is how many times is a factor or 0 occurring. So for example, if I factor and I get this, x minus 4, or if I get y equals that. Notice that x minus 4, you see it twice. So it would have a multiplicity of 2. The multiplicity of an x-intercept will tell you what it's doing at that point on the x-axis. So if you have an odd multiplicity, your graph is actually going to cross completely over the x-axis at that point. If you have an even multiplicity, your graph is going to touch the x-axis at that point, but it's going to turn back from where it came. So it's not crossing over. Odd multiplicity, it will cross the x-axis. Even multiplicity, it will touch it and turn back. Okay, the fourth thing we're going to use to help us graph is the y-intercept. And to find the y-intercept, you simply plug in 0 for x and solve. And you're going to plot that point on the y-axis. Okay, does anyone still need this? Okay. Okay, in your Math Excel, they're going to ask you, is your graph symmetric with the y-axis, x-axis, or origin? So, of course, you know if it's symmetric, all you have to do is fold it along that line and it should mirror. Both parts should mirror each other. So y-axis symmetry would, of course, look like a parabola, something like that. If you have origin symmetry, this is what origin symmetry looks like. If you've got, for example, if I've got the point 1, 1 on this graph, then you should have point -1, -1. You change the sign of both x and y. So origin symmetry is just going to be diagonal, like in diagonal quadrants. So that's what it looks like. An example of x-axis symmetry. You might have a graph that does something like that. So y-axis and x-axis symmetry are easy to tell, but origin is the one that's kind of weird. It'll be in diagonal quadrants. Okay, we're gonna do first example go through it step by step, of course. Okay, we're going to graph y equals x squared minus 8x plus 16. Step 1 says to find end behavior. And we looked at that in detail in section 5.1. What is your degree? What's the highest exponent in this? Your degree is 2. That's the highest exponent that you have. And what's the coefficient in front of x squared? What number is in front of x squared? 1. So it's positive. And in 5.1, it says if your degree is even and it's positive, has a positive coefficient, your end behavior, this graph should be going up on the left side. It should be going up on the right side. So when we finally graph it, somewhere over here, it should be going up. And then in this quadrant, it should also be going up. Okay, step 2. All right, we're going to find the x-intercepts or zeros. So this is definitely not factored. So if you'll recall from chapter 4, how would you factor this? Good, x minus 4, x minus 4. So it's x minus 4 squared. So you can write it like this, or you can simply say x minus 4 squared. Okay, one reason they call them the zeros is because if you're finding the x-intercepts or the zeros, what is your value of y? If you're on the x-axis, what is y? Y is 0. So anyway, that's how it factors. All you have to do now is take each factor, which they're both x minus 4, set it equal to 0 and solve. So what value would make this 0? 4. So your x-intercept or your 0 is 4. So this graph should be crossing or touching and turning back at 4. All right, step 3 was determine the multiplicity. How many times did you see x minus 4? 2. So it has a multiplicity of 2. So at x equals 4, that's an even multiplicity. So your graph should touch and turn. If it was an odd multiplicity, the graph would cross over the x-axis at 4. But you're going to see it's going to touch and turn back. What? Yeah, well, you're welcome. All right, step 4 was to find the y-intercept. And you plug in 0 for x and solve. What is your y-intercept? 16. So it's going to cross the y-axis at 16. An easy way to tell if your equation is not factored, your y-intercept should always be at the end, positive 16. Okay, now we have to go back and apply all of this information to help us graph it. Since my y-intercept is 16, I'm going to go by 2's on the y-axis. Okay, going back to the first thing. What you want to do, you know the end behavior, but we need to plot all of our points first. So let's plot, where did it cross the x-axis? Or where did it touch the x-axis? Your x-intercept is 4. So put a point on the x at 4. The other point was your y-intercept, which is 16. So when you're graphing polynomials, go through, find everything that we just did. Then you need to plot your points. After that, you start at your farthest left point, which of course would be my y-intercept. We said that the graph should be doing what on the left side? Is it going up or down? Good. So what you do, you start at that farthest left point. Using your end behavior, you either draw a curve coming down or draw a curve coming up. It should be going up. So, and this is just a sketch, okay? People that like to be like very accurate and have it going through every point that's on it usually don't like this. So draw it going up. Then it has to come back to your next point. So connect the dots from there. Stop here and go back to your multiplicity. Should the graph cross the x-axis here, or should it touch and turn back? Good, it's touch and turn back. So it's going to come down, touch 4, and it's turning and going back up. And then this in behavior matches up. We said it should be going up on the left side, up on the right side. It is. The graph should have touched that x-intercept and turned back, and it did. Okay, what questions do you have? Do you have any questions? Is it overwhelming to you? It's kind of different. It's just step by step. You just have to take that step by step. Yeah, go ahead. Yeah, I will. That's what I was going to do. Sorry. Okay, number 2, graph y equals, you have x squared plus 4 times x minus 3. Is this one factored or not factored? It is in factored form, which will help you find the x-intercepts quicker. Okay, step 1, find the end behavior. When we had polynomials that were already factored in 5.1, we found the end behavior by determining the degree of each factor. So if you just look at x squared plus 4, what is your degree, or what's your highest exponent? I mean, what is the only exponent? 2. So my degree for that part's 2. If you look at just the end, what is your degree of x minus 3? What's the exponent of x? 1. So my degree is 1. So your degree overall, you add those up, so you have degree 3. How you determine if it's positive or negative, what sign, or what's your number in front of x squared? Like, good, it's positive 1. So this was positive, and then you determine the sign here. My degree was 1. I have a positive 1 in front of x, so it's also positive. So a positive times a positive, you get positive. Since you have an odd degree and it's positive, your end behavior, your graph is going to go down on the left side and up on the right side. Are y'all okay with that so far? Have y'all looked at 5.1? Okay. Okay, step 2. Is determine your zeros or x-intercepts. It's already factored for you, so you simply take x squared plus 4, set it equal to 0, x minus 3, set it equal to 0, and solve. So here you get x squared equals negative 4. Can you take the square root of a negative number? No. Here we're in the, you can get an imaginary number back in 4.8, but we're dealing with real numbers. So we don't worry about here. We have no solution on that side. What's your only x-intercept? 3. So I have an x-intercept of 3. In step 3, we determine its multiplicity. How many times did you see x minus 3? Good, you only saw it 1 time. What if x minus 3 would have been squared? Then it would have a multiplicity of what? 2. Good. But you only see it 1 time, so it has a multiplicity of 1. Odd multiplicity. So what should your graph do at that x-intercept of 3? Good, it's going to cross over. Your graph is going to cross the x-axis. Okay, step 4, find your y-intercept. Plug in 0 for x. Can I go up a little bit? You're multiply them. Yeah, I know what you did. Good. So if you plug in 0 for x, you end up with 4 times -3, -12. So it should cross the y-axis at -12. Okay, so go back. The first thing you want to do when you're graphing it is plot all of your points. You only had one x-intercept of 3. Okay, so -12 would be down here. It's crossing the y-axis at -12. Okay, now after plotting points, use your end behavior. Start at your farthest left point, which is this, your y-intercept. What should your graph be doing on the left side? What did we say our end behavior was? Good. So I'll start at my farthest left point, which is here, draw a curve coming out, going down. It's got to come back up. And connect to your next point. Is it crossing the x-axis here or is it going back down? Was it crossing or was it touching and turning? Good. It's going to cross over and then it's going up. So that one kind of looks crazy, but make sure that you didn't, make sure it does kind of curve slightly. And it doesn't look like a line because it almost does look like a line. Okay, y'all have any questions so far about it? Okay, we're gonna look at one more and we'll call it a day. Okay, step one, determine in behavior. This is factored for you. So just go through, determine each factor's degree and sign, positive or negative. So if I look at this factor, this part, tell me what my degree is here of just this factor. Good. Degree is 2. Is it positive or negative? Is good. Positive 2 in front. What about the middle part? What is your degree? Degree is 1. Positive or negative? Good. It's got a positive 2 in front. The last factor, degree is degree is 1. It's also positive. So your degree overall is 4. Can't add. Degree is 4, and it's going to be positive. If you multiply 3 positives together, you get a positive. 5.1 says when your degree is even and it's positive, your graph is going up, up. Okay, second step was finding your zeros or x-intercepts. It's already factored for you. So take each factor, set it equal to 0, and solve. What does x have to be here? 2 times what is 0? 0. So x has to be 0. You have to be really careful in this case, though. What is this multiplicity going to be? How many times did you actually see x? Good. If x is squared, it's going to have a multiplicity. So that has a multiplicity of 2. All right, in the middle, if we solve this for x, you get x equals 1.5. How many times did 2x minus 3 occur? Good. It's got a multiplicity of 1. What is your last y-intercept? I mean, excuse me, x-intercept? -2. What's its multiplicity? 1. Okay, so in this case, we have 3 x-intercepts. Your graph at 0 should be doing what? It's an even multiplicity, so is it going to cross or touch and turn? Good, it's going to touch and turn back. What about at 1.5? And at -2? What's your graph going to do? It's going to cross over. Okay, last but not least, step 4, find y-intercept. Go through and plug in 0 for x. Look, guys, if you plug in 0 here, then you're going to have 2 times 0 times everything else. So what is it going to be? 0. Try to look for easy stuff like that to help you out. Plus, another giveaway that your y-intercept is 0, it crosses the x-axis at 0. So it has to be going through the origin. Okay, plot all of your points. It's crossing here at 0, 0. You've got an x-intercept of 1.5. And at -2. Start at your farthest left point. What was the end behavior? What should the graph be doing from this point? Should it be going up from this point or down? Should be going up. Your graph at -2 is going to cross over. We said it had a odd multiplicity, so it crosses through that point, but it has to come back and touch your next point. You can go down however far you want to go. If you want to carry it all the way down here, that's fine. Just kind of estimate or sketch it. So crossing comes back at 0. It had a multiplicity that was even. So it's going to touch and turn back, and then it's got to come back up and touch this point. And we said it crosses at that x-intercept. And always double check it's going up, up like we said it should be. It's crossing at those two. It's touching and turning back at that x-intercept. Okay, do you think this graph would have any type of symmetry? What'd y'all say? It's close. It looks like it might, but it doesn't. So it would not have any type of symmetry. The other graph that we did, this one, that one definitely did not have, well, I got it upside down. That one didn't have any type of symmetry either. So most of the time, they're not going to have symmetry. Okay, you've got, let me tell you, because I know it's been kind of confusing between last week and, well, this week too. In your Math Excel, I opened all of those up for chapter 5. You've got a 5.2 that says like polynomials, linear factors, zeros. Then I added a few for you to graph. So you've got a 5.2 part 2 graphing Math Excel. It's got 6 problems on it, 5 or 6. Okay,